Today we're going to be studying about right triangles. So we're going to be learning about the Pythagorean theorem. So most people know that the Pythagorean theorem tells us that a squared plus b squared equals c squared. So let's go over some of the terminology that we need to know. So a squared and b squared, these are our legs. C is going to be our hypotenuse. Okay, so the first thing you do with Pythagorean theorem problems is you label your A, B, and your C. The easiest way to label your C is right across from your right angle. So this is my C. My C is my hypotenuse. My A and my B are my legs. So this is one of my legs. This is my other leg. And so either one can be A, either one can be B. It does not matter. I could have called this one B. Could have called this one A. So the Pythagorean theorem tells us that the sum of the legs squared is equal to the hypotenuse squared. Okay, so let's solve a problem with this and let's prove that this is correct. So we have two legs given and we want to find the third. So also the Pythagorean theorem is used when you have two sides of a right triangle and you're trying to find the third. We have two sides, we want to find the third. So all we have to do is simply write out what we have. A squared plus b squared equals c squared. My A is 3. My B is 4. So 3 squared is 9. 4 squared is 16. So I have c squared is equal to 25. So the sum of my legs squared is 25. So let's see. C squared, the opposite of square, is to take the square root. So c here is going to equal 5. Now you can say plus or minus 5, but in this situation we have a side length, so it has to be a positive value. So c is equal to 5. So if I plug this back in, if I say c here is 5 now, if I plug 5 back in here, 5 squared is 25. 25 equals 25. So the sum of the legs squared is equal to the hypotenuse squared. Let's try one where we're doing some radical operations. In the previous videos, we spent a lot of time on radicals. Now we are going to use the Pythagorean theorem with radicals. So let's say we have, say I have 4, and I don't know what c is up here. So in this situation, once again, I have my two legs, and I'm trying to figure out what my hypotenuse is. Also, what you'll notice is the legs are congruent. So this triangle is going to be isosceles because it has two or more sides of the same. So we have the same thing, a squared plus b squared equals c squared. It doesn't matter what you call your a or your b. It can be either of your legs. So I have 4 squared plus 4 squared is equal to c squared. 16 plus 16 is c squared. 32 is going to equal c squared. Okay, so I don't know the square root of 32, but I'm going to be asked to write this in simplest radical form. So if I remember what my perfect squares are, I can pull out just a 16 from here. So this is the square root of 16 times the square root of 2. The square root of 16 is simply 4. So this is 4 square root 2. So the value of my hypotenuse here is 4 square root 2. And just like with anything else, you can double check this. 4 square root 2 squared. This is equal to 4 square root 2 times 4 square root 2, which is 16 times the square root of 4. The square root of 4 is 2. 16 times 2 is 32. And well, does that work? Well, 16 plus 16 is in fact 32. Let's do one more example where this time we're trying to find a leg instead of the hypotenuse. Okay, let's say we have, let's say this up here is 10, this is 5, Yeah, that'll work. And we don't know what b is, so we're trying to find out what b is now. Remember, my c is still in the same spot, so my a here is 5. 5 squared plus b squared, because b is my unknown, is equal to c squared. My c was 10. So 5 squared is 25. 25 plus b squared is equal to 100. Okay, so here we're trying to get b squared by itself. I'm going to move over my 25. So b squared is equal to 75. So now I simplify this radical. I can pull the square root of 25 out. It's the square root of 25 times the square root of 3. So I have 5 square root of 3. So this side up here is 5 square root of 3. So here I was solving for a leg, and all I had to do was get b squared by itself. Remember, we want our answers in simplest radical form, so I pulled out a 25. That's why the 5 is in front of the square root of 3. One more thing that you'll be asked is this a Pythagorean triple? Easiest thing in the world. Essentially, is it 3 whole numbers with no radicals? So here, this is not a Pythagorean triple. Here, we have 3 numbers, right? 3 squared is 9, 4 squared is 16, 5 squared 25. This is a Pythagorean triple. Why? Because the numbers are whole numbers. 5 square root of 3, if you wrote that as a decimal, that would be about, I think around 7. Sounds about right. Let's go with that. So that would not be a whole number. So if you have a radical or a decimal, no Pythagorean triple. All whole numbers, Pythagorean triples. And that's it for our first video on the Pythagorean theorem.